Hi everyone, please get this warm up from Canvas and work on it for the next few minutes. Pause the video while you do, and then you can unpause to check the answers. All right, this was a two-sample t-interval for the difference in the means between the two age groups, 15, 19, and 75 plus. So just a couple of reminders. Remember, we got our P section of pass is our parameters. So this is our parameter here, and then this is the procedure. Remember, you're deciding between one or two for the first number. It's either one sample or two sample. Here there's two samples because they had two separate groups. Then we have a T interval. So T is always for means. And then interval because they said the word interval right here. And then there's your parameter that we define in context. For the conditions, I like to check them for each group. So we had 15 to 19-year-olds and 75 plus year olds. I check them separately because you want to make sure you do that as two independent samples. And then our formula filled in. Now I wanted to show this one with the DF from the calculator because on this one, the sample sizes were so large that I would even the conservative DF would be super low estimate. We would use 974. So we would choose out of the two samples the smaller one and subtract one from that. So I just figured if we were already going to be estimating, we might as well let our calculator do it. So this is my note. That's from the calculator. Remember, I use a two-sample t interval, and so you just leave this. Well, let me do it down here. Leave as t star so that you don't have to find it. Now we could find it if we want to, so I'll show you if you wanted to actually find it. Remember, what you can do is so here's what I did in my calculator, by the way. Stat tests two-sample t and is this letter 0. We did not have data in our list. We had stats provided in the problem, and we had I made my age group 1 be the 15 to 19. There's their information. 75 plus their information. 95% was 0.95. It's usually that. And then leave it no pooled to calculate. And that's where I got this interval and the DF. Now to do the T star, we would do second vars 4. And so the area would be 0.025. Now I'm going to type in the DF 1101.193 and hit paste and get a T star of 1.962. Look how close that is to Z star of 1.96. And so I'll write leave as T star, or you can write T star equals 1.962. And it's so close to 1.96 because remember, as your DF approaches infinity, that's a Z star. So if you look at table B, my DF is close to 1,000, so 1.962 was there. You can always use that too. But anyway, you don't have to put it. You can just leave it as a variable as well. And so that's your statistical work, and then your summary sentence. Don't forget the units. Don't forget to say the word difference for a two-sample one, and the word mean here. So, all right. Now hopefully that was helpful, and you can see a little bit more about how to use the calculator. What we're going to do now is our activity called our AP Statistics Students Getting Enough Sleep. This is a two-part activity. We're going to do one sample and then two samples both today. So we'll start with this first one and we'll do a couple pieces of it together. So it's recommended that teenagers get 8 hours of sleep, but I believe you guys are probably getting less than that amount. So what I have done is taken a random sample of 10 students. So in class, what I would do is call on 10 different people using a random method and ask them how many hours of sleep they got. So I did this before with one of my classes, and I'm going to go ahead and copy down those values. Someone had 3 hours, so sad. We had 2 5s. We had 2 6s. We had 4 6.5s. And then someone got 9 hours, which is so nice. So that was one person there that got 9 hours. So go ahead and copy that down with me. And then I went ahead and calculated the mean of that. We had 6 hours for the group, 1.53 hours as the standard deviation, and this was 10 students that I called on, like it says in the problem. So I'm going to do number 2 with you before I let you continue on with this. Number 2, state the appropriate hypotheses. So it's been a while since we've done hypothesis tests. We did it, before in our last unit 6, but we haven't done any for means yet. So remember, what we want are HO and HA. Now we're doing for the mean, not the proportion. So remember, we have to put the parameter in, and the parameter this time is the mean number of sleep. So we're going to do mu. We have an equal sign, and we'll decide on the inequality for that later. And then here we look at the question. I am wondering, are students getting less than the recommended 8 hours of sleep per night? So is the true mean amount of sleep less than 8 hours? And remember, we always want to have the same number with the null with just an equal sign. Now let's define this variable. Mu equals the true mean amount of sleep, or true mean number of hours. Of sleep. AP Stat students get each night. Now, you guys should be able to do 3 through 6, I think 7, I'm sorry, 3 through 7 on your own. Now, number 6 is going to be a little tricky, getting the p-value. And so I want you to try to use table B if you can. And then I want you to pause when you finish number 7, and we'll go over it. So if you get stuck on 6, don't worry. You can pause you can unpause right around then, and I can go over how to do it. So just go ahead and try it, and we'll see if you can figure it out. And if not, I'll go over that before you move on to the next side of this worksheet. Okay, so here we have our answers for this beginning part, and we're going to do a little bit debrief, and I'll help you with number 6 as well. So first up, this is called a one sample t-test for mu. That's going to be our procedure. And then, we have our parameter here. These are our hypotheses, our null and alternative, so you should remember that. But make sure we're using mu now. So that's going to be the P part of pass, as we know. Then we have the A part of pass, which are assumptions and conditions. And I'm just going to write, these are the same as intervals, so we don't have anything special to do here like we did with proportions, which is really nice. We're allowed to just use the same 3. So that is kind of a perk. I will show you on number 3, the approximately normal one. If you actually do the box plot version of this dot plot here, you find that 9 is actually an outlier. And so we write proceed with caution when we have a condition that's not met. So I'm going to say use when a condition isn't met. Now, obviously we would prefer them to be met, but just a couple notes about that. On your AP exam, they will be met. So the last thing I want you to do is make a mistake and then stop doing the problem and say, sorry, can't do it, the conditions aren't met, and then not get any points. So I'd rather you just put a note like proceed with caution and miss the condition part than miss the whole entire problem because you thought it wasn't met. Second, they sometimes do ask you, I say they'll be met, sometimes FRQs on the AP exam will ask you, which conditions aren't met and why. So it's still important to see them when they're not met, like here. And then what does that affect? Well, it affects our normal calculation, so that's an important thing to think about when we look at our answers. But for now, 9 was an outlier. That person got a lot of sleep, and we're proud of them, but it did have make us proceed with caution on this activity. Number 4, we have our formulas for mean and standard deviation from a sample. Remember that this is our standard error. Ooh, I don't want to erase it. This is called the standard error, and so we want to use that instead. And then the mean is the null. So we use that to do our statistical work, and the statistical work is t equals the x bar from your sample minus the mean from the null over your standard error, s over the square root of n. So remember, a lot of this comes from here on this formula sheet. Go this way. So here's the formula again for standardized test statistic. We have statistic minus parameter. Sorry if this is giving you any whiplash. One more. There we go. It's delayed. Okay, so we have statistic minus parameter over standard error of statistic. Don't forget that on this page is where we have our statistics. These are our parameters. And then these are our standard error of the statistics. So in this case, s over squared n. And that's how you get your t. It's not a z-score. It's actually a t-score. So let's erase or cover over that. Remember, because we're estimating two variables. We're estimating the mu and the sigma. And so we don't know either one, and we are estimating with both. We do know the mu from the null, but we're testing the claim about it. So I got negative 4.13. And then number 6, both of these are our p-value, test statistic and p-value. Both of these are our statistical work. And so let me show you guys how I got that interval, 0.0025 to 0.001. So I have a t of 4.13, negative 4.13. So if I look at table B, the t's are inside. Remember, all of these are t's inside. And so I'm looking for my df to equal 9. So I'm going to look at this whole row right here. So our sample size was 10. And then none of them are negative, so we'll just pretend like it's positive. And I'm looking for 4.13, I think, right? Yeah, 4.13. So I don't see that, but I see 3.69 and 4.27. And so 4.13 would be between those, and then this is the p-value. So the tail probabilities are p-values. So I don't have an exact p-value, but I do know that it would be somewhere between 0.0025 and 0.001. And if you're uncomfortable with that, there's a better way, but that is one thing to do. And both of those are less than 0.005, so it doesn't, than the alpha of 0.05. So it doesn't actually matter if you get the p-value as a number or as an interval like this, but I do want to show you how to use your calculator to get the real thing, of course. So we're going to do t CDF. In this case, my lower would be negative infinity because it's to the left. Remember, it's negative. You start with negative infinity. My upper would be the t star. And then my df would be n minus 1, 9. So I'll show you how to get an exact value. Hit second vars, not normal CDF because it's not normal. It's a t curve. So we're looking at number 6. It's defaulted to be less than, so keep that negative 1e99 there. Put the z-score, or the t-score, 4.13, and fill in your df. Hit enter, and I got 0.0013, which is in fact between 0.0025 and 0.001. So don't worry about doing the intervals again if you know how to use the calculator. And remember, just separate with commas if you don't have the menu. And then last S, I'm just going to remind you, we haven't seen it in a little bit, that 1, we compare the p-value to the alpha. These steps are exactly the same as our last unit. So this is 1. Number 2, we reject or we fail to reject the null. So there, I did that. Number 3, we conclude that we have evidence or no evidence, or not enough evidence or convincing evidence. So that was right here. And then we want it to be in context. So that's here. So hopefully that is something familiar to you guys. And then I want you to now move on to the next page. And again, I'll help you with the first part and then you guys can finish the rest. So now we want to compare 2 different groups. So we did 1 sample T test and now we want to do a 2 sample T because they're very similar, so we don't need to have 2 separate days for this. The AP Calc teachers, they wonder, are their student sleep habits different from the AP Stat students? So the key here is differ. And then let's see what comes out, what else comes up. Here is the information for this calc group. And so our parameter is, we're looking at the difference between, but remember when we compare 2 groups, our parameter will be mu of stats minus mu of calc. We'll say that's the true difference in mean amount of sleep in hours per night for AP Stats and AP Calc students. So whenever we have 2 groups, we look at the difference in the mean amounts. So our null is no difference. US minus mu C equals 0. Our alternative is that the calc teachers were wondering, is there a difference? So just not equal to 0. We don't have a specific inequality to use because they didn't say whether they thought their students were more or less. They just said a difference. And so then our statistic will be the sample differences, x bar S minus x bar C. So you guys had 6, they had 6.125 as you can see here. And so that equals negative 0.125 hours. Now this procedure, it'd be great if you came up with it on your own, but I'm going to tell you because I want you to get the name right. It's a 2 sample because we have stats and calc. T because it's mean. Test because we wonder, is there a difference, not what is the difference. Remember, is there evidence of a difference, then there not what is the difference. So we have mu stats minus mu calc. Okay. So remember, I like to make 2 columns, one for statistics, one for calc. Check both. Try to apply what you learned from the 1 sample test to a 2 sample test the same way we did with proportions. These are actually even easier because there is not any difference between the formulas that we've been using. So you can still just do what feels the most correct, and you're probably right. And then your summary sentences will work the same stuff. So give it a try, and I will debrief it after you finish. So pause here and then unpause when you're ready. All right. So we already have our stuff all filled in here. Make sure you copied it, you got the same stuff. Parameter and statistic, I mean, those are the same as they've always been for 2 samples now. It's called a 2 sample t-test, so hopefully you got that. We did that together. Remember, this is always 0. And then you choose the inequality. Depending on the problem. You can subtract in whatever order you want, just be consistent throughout. And then we have to check for both. check for each group. We have this formula, now there's 2 samples, so we have to subtract. We want to draw our curve and label the DF. Instead of doing normal capital N 0, 1, we just put the DF on the top. I didn't say that before. So we just do the DF here instead of that because it's not normal anymore. And we don't know the standard deviation is 1. That's only true for z-scores, not for t's. And so don't do that. Just put this, the DF at the top, because that's what makes each curve different now. And then don't forget that when you have a not equal to in your HA, you double the p-value. So I got a negative t-star, and what that means is, or t-score. So here's my work, oh no, that's the old one. So what I do is second bar 6, keep my lower at negative 1e99, and then I put in the t score of negative 0.195. My DF in this case is my smaller sample size minus 1, which out of the 2 we have 10 and 16, so 9 still. And then paste. And I got 0.4249. But then that is just the left side, and so with a not equal to, you have to shade both sides, and so what you do is just double 0.8497. And so that's why I did that. Then we have our same 4 steps. Oops, nope. 1, put it here. 1, 2, 3, context. All right, now I think it might be helpful to also show you the calculator for this as well. So let's go ahead and do that. Stat tests. This one, we could do 2 SAMP-T test number 4. So this is stats again. My X-bar one was 6, standard deviation of 1.53. These are the stats students, so there was 10 of them. Then we had 6.125, standard deviation of 1.668, sample size of 16. Here, all you do on these 3 is choose the inequality you put in your null. Don't think anything crazy of it. If you have a greater than sign, put a greater than. If you have a less than, put a less than, and stuff like that. So in this case, we have a not equal to sign, so I choose the not equal to one. We keep it at no for pooled, and then calculate. And so I got t equals negative 0.196, and the p-value is 0.8468, which is close to what we got, but not exactly the same, and that's because of that DF equaling 20.5376. So remember, if you want to use that, just make sure you write the correct DF down here that goes with the p-value that you got. So you just have to make sure it matches. And then if you also, what you can do, I'll show you one more thing. I don't know if you guys noticed this, but when you go to stat tests, I think it was number 4, so let's click a 4. Everything's still in there, thank goodness. And I can click draw. And the reason why you could do that is it helps you draw the t distribution curve for the problem. Well, I have some other stuff in my Y1, but so it looks, ignore the lines, but this looks like the curve I drew. And so you just want to make sure you label DF equals at the top, and then copy that picture down for your picture if you want help drawing the picture. Okay, so why don't you guys, let's see, copy down this stuff from the Check Your Understanding, and then we will move on to the, copy down the stuff for the important ideas box, try to check your understanding, and then unpause the video when you're ready to check the answers. Okay, here are the answers. So again, let me just go ahead. This is just a 1 sample t-test, so we have pass, Here's our procedure, hypothesis, and parameter. We have our conditions, assumptions and conditions, and the alpha. We have our statistical work and our summary sentence. So remember, I like you to label your your normal curve, your bell curve here, the T curve in this case actually, with the DF on the top instead of the capital N and the 0, 1, because that's not exactly right. So just put the DF up there to label it, and then shade appropriately, get your p-value, and do the. If you want me to show you really quickly, I'll show you in the calculator how to do it again. So let's go to stat tests. This one's just called a t-test. You won't see anything called one sample t-test. They just, for the one sample ones, they just leave off that word, one sample. So it's a t-test number 2. And in this case, we don't have data. Data is a list. Instead, we have stats. So 4.77, or no, mean was 5. That's your null hypothesis. X bar was 4.77. S is 0.939. This was 30 locations, so N. We wonder if this is unsafe. So don't get confused by the little sub-zero thing. We're just wondering if it's unsafe. I had a less than sign for my HA. I choose the less than sign here. I hit calculate, and that's where I got the negative 1.3416 and the p-value of 0.0951. They're not going to tell you your DF on a one sample one, so that's because it's just N minus 1. Again, if I wanted to, I could hit the word draw, and maybe I should clear out my Y1 first. Okay. So we go to stat tests, draw. Oh, sorry, stat test, t-test, and then go down, instead of calculate, you can hit draw if you'd like. That will show you what your curve looks like. So here it's being drawn for you. So it looks like a normal curve, and then they shade to the left because it's a less than sign. And once it finishes drawing, see how it gives you your T and your P value, which is all you need. And so it's negative 1.34, so that's why it's at negative 1-ish, and then your P value. All right, thank you guys so much. If you have any questions, head to tutoring, try your homework, do your best. See you next time.